Hello everyone, in today's video we are discussing about the analog to digital converters. So what it will do, we'll see. Analog to digital converter does exactly opposite to the DAC. It takes analog as an input and converts it into digital as an output. ADC is provided with two control pins. So it has two pins, start pin and end of the conversion pin. And here we'll start a input initiating the conversion of the starting by giving the analog input and ending the conversion by indicating the output whatever we get in binary digit. Here also we have MSB and LSB bit. So MSB is the first digit, most significant binary bit, and LSB is our last significant binary bit, which is giving the voltage reference for our input. So here we have two types of DAC technology. So here we have two type of ADC technology. The first one is flash type. So flash type is nothing but this is also called as a parallel comparator, that is AtoD converter. It is simple, fastest and most expensive conversion. And we also say that the circuit consists of resistive divider network and has 8 op-amp comparator for 3-bit priority encoder. So for example, this is a op-amp and this is a voltage input we are giving and this is a voltage reference. This X is nothing but your output. So when this input is greater than the voltage reference, we'll get output as 1. If the input is lesser than voltage reference, we'll get output as 0. So V in is equals to VR previous value. So advantage of is high speed and number of comparators is equals to double. Disadvantage. So for example, if I want to use 5 bit, then comparator will become again 2 raised to n, that is 2 raised to 5 is nothing but your higher more comparator, which is a very biggest disadvantage. So here for 3-bit variable I am using 8 comparators. See, you can see I have total used 1, 2, 3, 4, 5, 6, 7, 8. 8 op-amp I am using. So what this 8 op-amps will do, this 8 op-amps will give signals and which will get in the binary output as our output, which is in Y2, Y1 and Y0. Let us see how this, see first of all you people know how to write the 3 variable. Yes, 3 variable is nothing but 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, this is 3 variable. This is only output you have to get for 3 variable. 8 encoder what we are using, 8 op-amp we are using. That means 3 variable consists of 8 inputs, right? So we can say x0 is nothing but our first input and x1, that is when we are having x0 is we have completed, when we are giving input to x1 we are getting 0, 0, 1, and x2 when we are giving we are getting 0, 1, 0. So this is how you will get your output. Similarly till x7 when we are giving the input we will get 111. So x7 value is nothing but your last 8th variable of the 3-bit. So here you can see I am telling when we are having x0, similarly for variable we will get for 16-bit variable, that is for 4-bit we are getting 16 inputs, right? If we are getting 16 input, then x0 when we are giving has 1 input we are getting 0, 0, 0, 0, and if we are giving x1 has 1 input we are getting 0, 0, 0, 1. Yes, similarly till x15 will get x14, x13, like this. Instead of here x7 we are going to add some more inputs of till x15. This is a simple logic. So next we have successive approximation type ADC. So here it will take analog as the input and we are using one comparator. So what this 4-bit SAR will do, it will take the serial data type and start the conversion. So it will take the analog input and it will check with the whether this analog input can give us the output or not. For example, if I am taking 100, whether this can be given higher value or lower value we have to check. And here comparator is used for giving the voltage follower to the SAR, that is 4-bit approximation. So this DAC, what it will do, it will even recheck the value of the input present in the analog. So it consists of a successive approximation register. The output which is connected to DAC as well as the output latch circuit. The input signal Vin is compared with the analog output of the VA of the DAC. The output of a comparator is a feedback into the SAR. The control logic inside a SAR adjusts its digital output until it is equals to the analog input signal.